Okay, so you're looking for the curvature of the vector valued function r of t equals e to the negative ti plus e to the tj minus square root 2 times tk. So this t, you have to look closely, but that t is not underneath the radical. So we're going to use this formula for curvature. K is equal to the magnitude of r prime cross r double prime divided by the magnitude of r prime cubed. So what does this formula tell us to do? Look inside the magnitude bars. We've got to find r prime, then r double prime, and then we're in business. So let's get to it. R prime of t is going to be e to the negative t times negative 1 by chain rule, right? So multiply by a negative 1 or just negative. That's times I plus the derivative of the next component is the j component, and the derivative e to the t is e to the t. So e to the tj, and then minus just square root 2 times k. Take the derivative of t, you get 1. Times square root of 2, you get square root 2. Okay, our double prime of t is going to be e to the negative t by chain rule, I plus e to the t j, just minus 0k, so we won't even write it down. Okay. Let's take the cross product. That's what the formula tells us to do next. R prime of t cross r double prime of t. Okay, so I, j, k across the top. Okay, let's put in the middle of this of this matrix I'm creating. Let's put in the components of r prime of t. So negative e to the negative t, e to the t, and negative root 2. Then for the bottom row, let's put in the components of r double prime, e to the negative t, e to the t, and 0. Okay. We take this cross product and, okay, cross out the first column and take the determinant of the remaining matrix. So what does that give you? Well, that's e to the t times 0, right? So this guy times this guy, and then minus this guy times this guy. So that's just going to be e to the t times 0 is 0 minus e to the t times negative root 2, which will just be plus. Let's put the root 2 in front. Root 2 e to the t. So I can see right now I'm going to run out of room. Let's move this down here. And then it's that times I, right? Minus, by definition, a minus there. Now cross out the middle column, and you end up taking the negative e to the negative t times 0, so that's 0, minus negative root 2 times e to the negative t. So we have a built-in minus, and then a minus right here. That's going to make a plus root 2 e to the negative t. And that's times j. And then if you cross out the last column and take the determinant of this matrix, you end up with, okay, by definition you get a plus here. Okay, it's going to be negative e to the 0 power, because if you multiply these guys together, you have like bases, keep the bases, add the exponents, you get 0 as your exponent. So that's just going to be negative 1. And then minus e to the t times e to the negative t, which is minus 1 times k. So cleaning it up, it looks like for the cross product we get square root 2 e to the t minus square root 2 e to the negative t minus 2k. Alright, let's take the magnitude of this. So the magnitude of r prime cross r double prime, I lost my of t function notation. That'll happen to you too. You'll get tired of writing it down. Okay, we're going to square, oh, by the way, I lost my I and my j here. I got in a hurry there. Okay, so we're going to square the I component, and that'll get us 2e to the 2t if you think about it. E to the t times itself must be e to the 2t. And then plus, okay, square root of 2, you get 2 e to the negative 2t. If you take e to the negative t times itself, you get e to the negative 2t plus 4. Okay, let's talk about r prime, magnitude of that to the third power. If you look at that formula I wrote down, that's what we need to compute for the denominator when computing curvature. So we know what r prime is. R prime is this guy. So if we square each term, add them together, put it underneath the square root, what does that give us? Well, we're going to get e to the negative 2t for the first term. So square root e to the negative 2t for the first term plus e to the 2t for the second term if we square e to the t. So plus e to the 2t for the second term, and then for the third term just a plus 2. And then we're going to take all that and cube it. Okay. So for curvature then, kind of a raw formula would be, well, take this guy over this guy. But I think we can probably simplify that. But anyway, we'll do that to start. So we'll take the square root of 2e to the 2t plus 2e to the negative 2t plus 4 and divide it. So that's magnitude r prime cross r double prime magnitude of that. I already said that. And then divided by the magnitude of r prime cubed would be the square root of, let me change the order here, e to the 2t plus e to the negative 2t plus 2. Okay. So I'm thinking I could factor out a 2 underneath the radical, and which means I can pull out a square root of 2. So I can pull out a square root of 2. Oh, sorry, and this guy is cubed. Okay. So I can pull out a square root of 2, and what's left then underneath the radical on top is e to the 2t plus just 1e to the negative 2t plus 2. It's looking familiar. And then on the bottom, maybe I'll rewrite instead of writing this as a square root up top, maybe I'll write it to the 1/2 power so we can really see what's happening in the next step. And then maybe I'll write this one to the 3/2 power. So when you take a square root cube, that's a 3/2 power. So e to the 2t plus e to the negative 2t plus 2 to the 3/2 power. So hopefully you can see we've got like bases in the numerator and denominator as far as this big quantity in parentheses is concerned. And so we can keep the base, subtract the exponents, which if I left it in the numerator, it'd give me negative 2 over 2 when I go 1/2 minus 3/2. But in the denominator then, it's just the 1 power, isn't it? Negative 2 over 2 up top would be to the negative 1 power. So yeah, square root of 2 over just e to the 2t plus e to the negative 2t plus 2. Whoops. But you'll notice that this isn't exactly what the given answer was. But if you look at the given answer, it gives a clue as how to maybe simplify this. If we multiply, the given answer has an e to the 2t up top. So if we multiply numerator and denominator by e to the 2t, then, okay, on top, of course, we have the square root of 2 times e to the 2t. And then if we distribute the e to the 2t on the bottom, we'll get e to the 4t when we distribute it here, plus, well, 1 when we distribute it here, plus 2e to the 2t when we distribute it to the 2. And I know that doesn't look much simpler, but there's a neat trick here. If you reorder the addition in the denominator, you get e to the 4t plus 2e to the 2t plus 1, and that turns out to be a perfect square. It'll factor to be e to the 2t plus 1 squared. I know that. The reason I know that is I know a formula from algebra. A plus b quantity squared is equal to a squared plus 2ab plus b squared. And so all I did was factor this, going from kind of this side. I recognized, oh, this is a perfect square, where a is like e to the 2t, and b is like 1. And once you recognize that, it's pretty quick to see, oh yeah, so I can factor this guy as e to the 2t plus 1 quantity squared.